Many times in the lab, when we are doing some practical work, we need a solution with a certain concentration. But when we go and try to look for it, we do not find it. Instead, we find a more concentrated solution. So what should we do? Should we prepare a brand new solution with the concentration we need? No. Instead, what we can do is we can dilute our concentrated solution, and that way, instead of using more reagents, we can reuse the reagents already present in our concentrated solution. For example, here we have this beaker with these solute particles, and this is an example of a concentrated solution where there is very little total volume and lots of solute particles. Here, however, we have lots of volume of our solvent. This is a more dilute solution. Now, if we had to quantify both of these, we can divide the number of moles of the solute by the total volume. Because the volume is low, the concentration will come out to be a larger number than here, where we have the same number of solute particles but the volume is high. So because the denominator, when we do the division of the number of moles by the volume being larger, the concentration will be lower. So in a dilute solution, the concentration is lower than in a concentrated solution. Now, how exactly do we perform a dilution in the lab? In reality, we don't store our solutions in beakers, but there are other special containers, special glassware made just so that we can make solutions and we store them. Usually the lab tech would make a concentrated solution in a glassware called a volumetric flask and then store it in stock bottles. Many times those bottles in which the concentrated solution is stored are called stock solutions. And whenever, as circumstances call, and when a dilute solution is needed, the lab tech would use the concentrated solution to make more dilute solutions. Now, the way it works is you transfer a certain amount of the concentrated stock solution into a new volumetric flask in which you are making a dilute solution. Let's say that the total volume of the volumetric flask is 1 liter, and you transfer 100 milliliters of your original concentrated solution in that 1 liter flask, and then you have 900 milliliters of space remaining inside the volumetric flask, which you fill up with your solvent. Let's say it's DI water. Then you shake it after you stopper it, and then you can use that solution as a dilute version of the original concentrated solution. How dilute is the new solution? Well, we only took 1/10 of the number of moles present in the original solution and we diluted it with 9/10 water. So the dilution is a tenfold dilution. Whatever was the original concentration, let's say it was 20 molars, our dilute solution is 2 molars then. Now, it's easier said than done, but if you were to actually do this, the way you would solve this kind of problems when you are trying to make a dilute solution is by using a simple calculation where molarity 1 times volume 1 equals molarity 2 times volume 2. Here, molarity 1 represents the molarity of the original concentrated stock solution, and volume 1 represents the amount of the stock solution which was transferred into the other volumetric flask in which we made our dilute solution. V1 does not represent the total volume of the stock solution. It represents the volume transferred into the dilute solution. And then molarity 2 will be the concentration of our new dilute solution, and V2 is the total volume of our dilute solution. The reason this equation holds is because molarity m times the volume gives us the number of moles of the solute. And since the number of moles of the solute obtained from the stock solution is the same that show up in our dilute solutions. That's why when we multiply the concentration times the volume obtained from the stock solution must equal to the concentration of the dilute solution times the volume, total volume of the dilute solution. Let's have a look at a problem. Calculate the molarity of a solution made by diluting 0.050 liters of 0.10 molar HCl solution to a volume of 1.0 liter. Now this is not a difficult problem, but the challenge is that we know that M1 is the molarity of the stock solution and M2 will be the molarity of the resulting desired solution, our dilute solution. We do not confuse the two and assume that the molarity given here is that of our dilute solution. For that we need to read the question carefully. Calculate the molarity of the solution made by diluting a certain volume of 0.10 molar HCl solution. So if we are going to make a dilute solution, and if this is the solution we are going to use to make a dilute solution, then this must be our original concentrated solution. So if this is the concentration, that must be the value for M1. And we are being asked to calculate the molarity of a solution that's made, meaning that we are being asked to find M2, our dilute solution concentration. Apply the same logic in finding which is V1 and which is V2. If we are taking 0.050 liter from our concentrated solution, then that value is V1. V1 equals 0.050 liters. And if we are making a solution that's total volume is 1 liter, 1.0 liter, then that's V2. With all that said, we can arrange all of these values in equation and isolate our desired term, the value for M2 on one side, and M2 will equal to M1 times V1 over V2. Notice how the units of liter cancel out here and the units of concentration remain, and that is the concentration of our dilute solution. So our original concentrated solution was 0.10 molars and our dilute solution is 0.0050 molar. It's a very dilute solution by more than 10 folds.